Algebraic equations we're going to solve by factoring. To do that, you want to get all the terms on the same side of the equation so that it's equal to 0. Then you want to try to factor it. If it's a trinomial, 3 terms, and your leading coefficient is a 1, which it is in this case, this is the easy type to factor. It just goes right into 2 binomials. The first term in each of your binomials is going to be the square root of the first term in your trinomial. Square root of x squared is x. The second term in your binomial, in each of them, is going to be found by finding the product of negative 35 and two numbers. I misspoke there. You need two numbers whose product is negative 35, and those same two numbers add to be the coefficient of x, which is a negative 2. Those such numbers are negative 7 and positive 5. You multiply those, you get negative 35. If you add them, you get negative 2. So in one of the binomials, I'm going to put a minus 7. The other I'm going to put a plus 5. Doesn't matter which is which. If the product of two things is 0, that means one of the two things you're multiplying has to be equal to 0. So we're going to set both these equal to 0, solve this, and we get that x could be negative 5 or 7. A rational equation is an equation that has fractions. So one way to do this problem, well, I should mention, whenever you have a rational equation, there could be excluded values. Excluded values come from the denominator being equal to 0. So this denominator is 2x minus 2. That cannot equal 0. This denominator is x squared plus 1. That also cannot equal 0. If the denominator is equal to 0, it's undefined. So if you solve each of these equations, you get that, I did some algebra wrong there. If we add 2 to both sides, we get 2, and then divide by 2, we get x can't be 1. The second equation, which I miswrote, is x squared minus 1 doesn't equal 0. We're going to get x squared doesn't equal 1, so x can't be plus or minus 1. So we get to the end of this problem. If either answer is a positive or negative 1, then those answers don't work because that makes this problem undefined. So now that we got that out of the way, let's try to solve this equation. One method would be to get rid of your denominators. So if I multiply both sides by x squared minus 1, which the short version of that is to cross multiply, you're going to get 5 times the difference of x squared and 1. I multiply both sides by 2x minus 2, top and bottom. Or, pardon me, just multiply the tops by 2x minus 2. That's equivalent to getting 15 times the difference of 2x and 2. If I use the distributive property, I'm going to get 5x squared minus 5 on the left. On the right, I'm going to get 30x minus 30. When I get all the terms on the same side and then factor, so it's going to give me 5x squared. If I bring the 30 over to the left, it's going to be a minus 30x. If I bring the minus 30 over as a plus 30, it's going to be plus 30 minus 5 is a plus 25. When factoring, the first thing you should always check for is the GCF. My phone's ringing, pardon me. Try your best to ignore it. And that's going to be 5 times x squared minus 6x plus 5. And then once again, we're fortunate, this is a trinomial in which the lead coefficient is 1, so we need two numbers that multiply to get 5 and add to get negative 6. That's going to be x minus 5 and an x minus 1. Set each factor equal to 0. 5 equals 0, which doesn't make any sense, so we're going to say 5 doesn't equal 0. And then we got x minus 5 equals 0. And we got x minus 1 equals 0. So we end up with solutions of 1 and 5. But if you look back, we said earlier that x cannot be 1. So this answer does not work. So the only possible answer for this is 5. Number 12. If x doesn't equal negative 4, and the reason it doesn't, because that would make the denominator 0, what is the set of all possible values for x? Well, if you have a fraction equal to 0, you want to set the numerator equal to 0, because 0 divided by anything is 0. So 4x cubed plus 8x squared minus x minus 2 equal to 0. We're going to factor this by grouping. We're going to group the first two terms together. Grouping means putting them in parentheses. Plus, group the last two terms together. When you factor by grouping, you need a plus sign between your groups. Putting a subtract there, unless you're super advanced, is most likely going to lead to heartache. Find the GCF of each group. The first group, the GCF is 4x squared, leaving us with x plus 2. Second group, the GCF is negative 1, leaving us with x plus 2. If done correctly, your two binomials are going to be the same, so we're going to factor those out to the front, because that's the new GCF, leaving us with 4x squared minus 1. We are then going to set each of these factors equal to 0. We got 4x squared minus 1 equals 0. And we got x plus 2 equals 0. So one answer is negative 2. If we solve this other equation by adding 1, dividing by 4, square rooting both sides, we get plus or minus 1/2. So there's three answers. Negative 1/2, negative 2, positive 1/2. Remember, when you take an even root of a radical, you get two answers, plus or minus. Number 13, radical equation. What's the value of x? If you have an equation that has a radical in it, and you want to solve for x, you need to first get the radical by itself. Then, you need to get rid of the radical, and to do that, we're going to square both sides of this equation. As mentioned earlier, squaring a square root cancels, so we have x minus 3. On the right, if we square this binomial, we're going to get x squared minus 10x plus 25. If we get all the terms on the same side, if we subtract x from both sides, we're going to get negative 11x. If we add 3 to both sides, we're going to get plus 28. This factors into an x minus 4 and an x minus 7. Minus 4 plus a minus 7 is negative 11. It's the middle term. A minus 4 times a minus 7 is a plus 28. Set each factor equal to 0. And we end up with 4 and 7 are the possible answers for this problem. Now, one thing that should be mentioned, anytime you have a radical in an equation and you solve it for a variable, you could end up with answers that actually don't work. They're called extraneous solutions. So we need to check these answers to see if they work. If I put a 4 into this, that's going to be 4 minus 3 equals 4 minus 5. 4 minus 3 is 1. 4 minus 5 is negative 1. Square root of 1 is 1. Does 1 equal negative 1? It does not. So that's not an answer. If we check the 7, that'd be the square root of 7 minus 3 should equal 7 minus 5. 7 minus 3 is 4. 7 minus 5 is 2. Square root of 4 is 2. 2 does equal 2. So the only answer that actually works for this is 7. Exponents in algebraic equations. I guess this one here doesn't actually have that. It's just a rational exponent. Find the value of x to the negative 2/3 if x is 27. So we're going to substitute 27 in. Then we're going to use our properties that we just discussed at the beginning of this lesson. Do this in lots of different orders. Let's say that we want to change this to a radical form first. It's going to be the cubed root of 27 to the negative 2. This negative can go on the top or the bottom, so it could go with the 2 or the 3. The cubed root of 27 is 3. If we want our exponent to be positive, we reciprocate the base. And then, if you have a fraction to an exponent, you apply the exponent to the top and the bottom. 1 squared is 1, 3 squared is 9, so the answer is 1/9. One more. Here we have exponents that are variables. We want to get these bases, 4 and 8, to be the same number. If we can get those to be the same number, we can set the exponents equal to each other. 4 is the same as 2 squared. There was already an exponent, so I'm going to put that in parentheses and put the original exponent on the outside. 8 is the same as 2 cubed. Put that in parentheses because that was already raised to an exponent of 3x minus 6. Power to a power property, you multiply the exponents. Power to a power property, you multiply the exponents. Once your bases are the same, then you can set the exponents equal to each other. I'm going to subtract 2x from both. This is a 2x, not 2 to the x. I'm going to subtract 2x from both sides of the equation. I'm going to add 18 to both sides of the equation. Divide both sides by 7, and you get x is 22/7. Should be able to complete the entire exercise set 5 at this time.